Welcome to Chapter 2, Exploring Data with Tables and Graphs. In this video, we'll be covering Section 2.1. The best thing to do is to have your textbook out. And for this one, we're actually going to be creating tables, or you might want your calculator handy and get ready to take lots of notes and follow along with me and do lots of pausing so that you can keep up and keep track. So the key concept is when working with large data sets, a frequency distribution or a frequency table is helpful in organizing and summarizing data. We'll also be using a frequency distribution to help us understand the nature of the distribution of a data set, and we'll be talking about that in this section and then again in later sections. The vocabulary and important terms for this really has to do with the frequency distribution itself. Alright, so it shows how data are partitioned among several categories, or we use the term classes, by listing the categories along with the number or frequency of data values in each of them. So don't let the word frequency kind of bug you out here. If we had, some data and I wanted to know the frequency of a 5, so the frequency of a 5 would be, 2, 6, 1. So we're just counting like how many. So I'm going to show you a frequency table here. So this frequency table has the time in seconds for a McDonald's lunch drive-through service time, and then the frequency that the service occurred in that time frame. And we're going to be using this example a lot. So let's go through these definitions of what makes up this table. So a lower class limit is the smallest numbers that can belong to different classes. So first of all, these are your different classes. This is a class, this is a class, these are different classes. There are 5 classes in this frequency table. And the lower class limits are these numbers right here. That is a lower class limit. Then an upper class limit are going to be the larger numbers that belong to each class. So these are your upper class limits. Now, a little more work here is a class boundary. So a class boundary is the number that used to separate the classes, but without the gaps created by the class limits. So if we took a look here, there's a gap between 124 and 125, and then between 174 and 175. So a class boundary eliminates the gap. So what I'm going to do is I'm going to actually list everything out. So we've got 75 to 124, and then we've got 125 to 174. We've got 175 to 224, and this is how I'm going to figure out my class boundaries. We've got 225 to 274. 275 to 324. Okay, now the class boundaries are the numbers that are right in between here. So how we actually calculate these is we want this number right here. So we're going to take these and kind of split the difference or add them up and then divide by 2, and we get 124.5. And you might see the pattern right away. Well, what's exactly in between them? And these are our class boundaries. And we also need to not forget to grab the class boundary at the end and at the beginning. And you can kind of follow the pattern to see what they would be. And those are the class boundaries. The class midpoints are the values in the middle of the classes. Each class midpoint can be found by adding the lower class limit and the upper class limit and dividing by 2. So the class midpoint here, so if we go back, we've got 175 to 124. The midpoint would be 75 plus 124 divided by 2. We're going to get 99.5. And then the midpoint between 125 and 174 is going to give us 149.5. And then the next midpoint, and you might see the pattern, and it's totally fair game to just use the pattern or type it into your calculator. Oops, I'm just giving you the answers now, sorry. 225 plus 274 divided by 2 is going to give you 249.5. Now these are super important for our next section when it comes to graphing these. We're going to be using our midpoints. And that's how you find the class midpoints. Now, the class width is the difference between 2 consecutive lower class limits. So that would be these. Now, you could also use the upper class limits if you wanted, but the a common mistake is to subtract the lower and an upper. And we actually don't want to do that, so just be super mindful. Class width, so it'd be 125 minus 75, so the class width is 50. Okay, so how do you construct one of these? Now that we've navigated what each part is, how do we actually make it? So I'll go through the 6 steps and then we'll do an example together and then I'll give you a you-try problem. So first you select the number of classes. Now sometimes that's provided to you, but usually it's between 5 and 20. Now just to recall here, the classes are these here. So this has 1, 2, 3, 4, 5. I personally wouldn't want 20 classes, but you wouldn't want to pick 2 classes. That's not going to give you enough information. To calculate the class width, so the class width, if you recall, is the difference between those lower limits or those upper limits. So to calculate the class width, we would take the maximum data value. Now remember, we don't have the table yet. We just have a bunch of raw data. We would take the maximum value, subtract the minimum value, and divide by whatever we decided in step 1. Did we want 5 classes? We would divide by 5. Now, you might end up getting like 22.2 or 37, and we want to make this a nice number. It's usually best to round up and make it a little bit bigger, so you could say 25 or 30 or 40, a nice whole number. Next, you choose the value for the first lower limit. Let's go back here. The first lower limit here was 75. So we want to choose the value for the first lower limit by using either the minimum number or convenient value. So if my minimum number was 71, I might use 70 or 65. You again have a little freedom here to choose kind of nice, pretty numbers, if you will. Now, you have the first lower class limit and the class width. So the first lower class limit is here. The class width you calculated here. So now you can list all the lower class limits. And again, we're going to do an example of this together. Once you list all the lower class limits in vertical column, so you're kind of looking at it like 75, 125, 175, all your lower limits, you're going to calculate your upper limits. And that's going to be based on, well, what's 1 less than 125? It's got to be 124. What's 1 less than 175? 174, because you don't want any overlap. And then you take each individual data value and put a tally mark in the appropriate class, and then you add the tally marks up to get a frequency. So we're actually going to look at the raw data from that frequency table we've been looking at. So we know the answer already, but we're going to go through it from beginning to end. So here's the raw data. And this is what we're going to start with. So step 1, we have to determine the number of classes. But if we look at the directions, it tells us, boom, use 5 classes. So step 1, which was to determine the number of classes, is done for us. Now, if we go back, step 2 has us calculate the class width. We need the maximum data value and the minimum data value. So let's look through here. What is our maximum data value? And what is our minimum data value? Give you a moment to find the data values. Once you have the maximum and the minimum data value, you'll subtract them and then divide it by 5 because that's our number of classes. And hopefully you found these numbers. Now, when we divide it, we get 45. Again, remember, you get a choice with your class width. We had 45, let's just make it 50 because that's a nice, convenient number. And certainly convenient is relative. You may say, I like 45, but 50 is a nice, easy number to add and subtract with. So, step 3, choose the value for the first lower limit by either using the minimum value or convenient value below the limit. So, below the minimum. So our minimum was 83. I'm probably not going to start my frequency table with 83. And neither did they. They said the minimum value is 83, but that's not a great starting point. So if we're looking at 50 as our class width, let's just start at 75. And that's how they came up with 75. So there's a lot of choice when you're developing these frequency tables. So now let's go back and look at step 4. Step 4 has us listing all the lower class limits. So if we add the class width of 50 to the starting value of 75, remember we said we were going to start at 75, we're going to list them out. So we've got 75 plus 50 we're going to get 125, and we're going to get 175 and 225 and 275. Now, why didn't I keep going to the 325? Because my maximum value is 308, and I don't need to go past 275, because if I was to do 325, I know I'm not going to have any data in this category, so I don't need to do that. And lo and behold, that's what we did. And then the next thing we do is we figure out the upper limit. So we would say, okay, 125, what's less than that? 124, 174, and so on. And then step 6 has us actually going through the data and tallying what falls in between. So we would go back into our data and we would say 107, where does that fall? 107 falls right there. I promise I'm not going to do it for every single one. 139, where does 139 fall? Falls right there, and so on and so forth. Once you get all your tally marks, you add them up and you would see you have 11 in that section, 24, so on, and that's how you get the frequency table. Pause the video and go ahead and give this a try. This one's a little bit different. They actually give you the class width and they give you the first lower limit. So see if you can try this. It's a little more difficult, but go through the steps and press play when you're ready to see my work and the answer. Please make sure to pause this to see how I made sense of everything and then keep going. A relative frequency distribution, instead of the class frequency, the tally marks, it's a percentage of the total. So to get the relative frequency for a class, you would take the frequency and divide it by the total. And to get the percentage, you would just multiply it by 100, just like we talked about in a previous video. So if you take a look here, on our left, we have our frequency table, and on our right, we have our relative frequency. So how did we come up with that relative frequency? Well, the total, if we were to add up all these values, we're actually going to get 50. So if we were to take 11 and divide it by 50, we would get 0.22, which is 22%. 24 divided by 50, we're going to get 0.48, which is 48%. And that's how you calculate the relative frequency. And that's an example 2. Cumulative frequency. Cumulative means all of the ones before it. So the frequency for each class is the sum of the frequencies for that class and all the previous. So notice that they changed this. It says less than 125. They're using the upper limit of that before it. And then everything that's under 125 would be 11. How about under 175? Well, that's both of these, and that's how they came up with 35. And so they add it up, and that's how you get the cumulative frequency. In statistics, it's a common question you're going to hear a lot in this course, which is, does the data have a normal distribution? And so for something to be normal, it would start low, increase to its maximum, and then lower back down again. It would be approximately symmetrical. And gaps also show more information, but they're not necessarily a normal distribution. So if we take a look here, the table shown is a frequency distribution of the weights of randomly selected pennies. What could the large gap mean? You can pause this and try on your own or stay with me. So we've got that clearly a lot of pennies weigh that much, and then clearly a lot of pennies weigh a lot more. So what do you think that means? They're probably made of different material. And so if we think about it in terms of what pennies were actually made about before 1983 and after, it makes sense that we would have a gap between the two. Sometimes we like to compare two or more relative frequency distributions because it makes it easier if it's all in one table. Here's an example. We've got the relative frequency for the McDonald's drive-thru times and then the Dunkin' Donuts times. What do you notice? What do you wonder? What do you think? So one thing that I notice is there's a big dramatic difference in menus between McDonald's and Dunkin' Donuts. Dunkin' Donuts is just kind of quick coffee, so it makes sense to me that they're going to have quicker times than McDonald's. Go ahead and give this one a try, and then press play when you're ready to see the answer. And that concludes section 2.1.